Hi guys, I am Tandiwe and I'll be doing binomial distributions for you. The question we're going to be working on is on page 214 in the blue book, our stats book, and it will be number 14 on binomial distribution. So the question reads as follows. Human error has been given as the primary cause of error in 70% of accidents in the industry. You may assume that errors are independent of one another. So part A of the question says to find the appropriate random variable and state its distribution, right? So the random variable that we're defining is x. So for A, let x denote the number of accidents caused by human error. And the second part of part B says that we must state its distribution. So because of the fact that it's a 70%, it's 70% human error, 70% not human error, and therefore that's how we know that it's a binomial distribution. So it's a yes or no situation. So x is distributed binomially with parameters n, which we don't know yet, and a pi of 0.7, right? So that's your A done. Part B says consider a random sample of 32 industrial accidents. So we changed the 30 to 32 of industrial accidents. Calculate the probability that human error in the primary is the primary cause of these accidents for, and the criteria goes down. So part A says that x must be more than 25. Must be more than 25 of the accidents, right? So we're finding the probability, part B, right? We're finding the probability that x is greater than 25. Okay? So, in terms of our binomial distribution, we could work it out in two ways. We could use the formula, or we can use the table, which I will show you both ways to do. But firstly, we need to just take care of this little situation here and find out what exactly this means, right? So what we're looking for anything above 25 till 32. So our n actually is 32, right? So we're looking for anything that is above 25 to 32 in our sample space. So that means we're looking for 26, 27, all the way to 30, right? So this is basically the probability that x is greater or equal to 26. Okay, so in using the table, okay, let's first start off with the formula because that takes a bit more time. So the formula is basically saying that the probability that x is equal to, the smaller x is equal to the sample size, choose the x, times by the possibility of success to the power of the x, times by 1 minus the possibility of success, all to the power of n minus x, right? Yes?
I'm sorry, I think on 26, 27, is it supposed to be to 30 or to 32?
Sorry, to 32. 32, thank you. So the sample size is 32. Okay, thanks. Okay. Back to the formula, right? So what happens is that you need to be careful with this. The formula basically tells you if you're going in the right direction. So this, the x here and this must give you the total 32, right? Or the total n. Then you know you're in the right direction. This number here, the pi and this number in brackets must also give you 1, and then you know you're in the right direction. You're going in the right direction. So in terms of using the formula, you're basically going to say that the probability that x is equal to 26 plus the probability that x is equal to 27 plus the probability that x is equal to 28 plus the probability that x is equal to 29 plus the probability that x is equal to 30 all the way to 32. So you're going to repeat all this until you get to 32, right? So I'm only going to do just one of these probabilities and then you can put the rest and you'll find the same answer we're going to get in the table. So just putting the formula into actual practice is that the probability that x is equal to 26 is n, choose 26, times by the pi, which is 0.7, the possibility of success, right, which is 0.7, to the power of 26 times by 1 minus pi, all to the power of 30 minus 26. 32, thank you. 32. Right? Oh, 32 to the power of 36. Sorry, this n is supposed to be 32. So it's 32, choose 26, times the possibility of success to the power of 26, times by 1 minus pi to the power of 32 minus 36. 26. So the answers that you get here must both equal to 32, and you know you're on the right track. And you basically do this for all of these until you get to 32. But we are going to use the formula, the table, right? So the one thing that you need to be careful of in the table is that the table, which is on page 244, only gives you values that are less than or equal to r. So now the problem we have with this part of this is the fact that our sign is facing the wrong direction. So we need to find a way to change this so that it gives us so we can go into the table to look for this figure. So basically, I'm just going to drag this all the way here. Alright. So basically what we're going to do is that we're going to say, because you know the probability is equal to 1, right? So if the probability is equal to 1, if you're looking for something else, you can find the probability of it not being to actually, and then subtract that from 1 to get the proper probability. So we can basically say that we can find the probability of everything less and equal to 25, subtract it from 1, and it's going to give us the probability that it's more than 26. Okay? So then we're going to say 1 minus the probability of x being less than or equal to 25, right? And you're going to go to your table, and then you're going to go to n. Well, your table has, yeah. You're going to go find your n, which is 32, and then your r is your 25, and the top, yeah, the pi is at the top, and it's 0.7, which is not on the table. So then it means that we need to find the probability of the failure. Yeah. Right? Okay, so now the problem is that 0.5 is not in our table. Yeah. 0.7, sorry, is not in our table.
Okay, so I just wanted to ask, why do you have now 25 here, but there you have like 26? Why can't you change it to 26?
Okay. So now the thing is, remember when we said that in our table, we're looking for values that are less than r.
Mm-hmm.
So then the problem with this 26 is that we're looking for values that are more than 26 and must include the 26.
Yeah.
So now it means that from this line, from the 26 onwards, we're fine.
Mm-hmm.
But the 25 downwards, we don't want it because we're supposed to remove the probability of everything 25 and downwards from the 1. Right?
Mm-hmm.
So the reason why we include the 25 is because we say that the 25 also must go. So 25, 24, 23, everything downwards must go. We only want the 26, 27, 28, and 30. And that's why we convert when we say it must be less than or equal to 25. Do you get it?
Okay.
Yeah. Okay, so now on to carrying on. So we've said that 0.7 is not on the table, so now we have to look for x prime, right? So in looking for x prime, I'm going to remove all of this now. Okay, so now in looking for x prime, we know that x prime basically is the opposite of this because it's the possibility of a failure, right? So then x prime then is distributed binomially with n of 32 and 0.3 as a possibility of failure. So now in looking for, okay, with x and x prime, when x happens, x prime doesn't happen. When x prime happens, x doesn't happen. So we're looking for everything that's more than the 26. So we have 26, 28, 29, 30. So these are values of x, now.
What about 27?
Oh, thank you. 27, 28, 29, 30, 31, and 32. Okay? So x in the complementary of x. So we know that if you have 32 accidents that are caused by human error, you're going to have 0 accidents that are not caused by human error. And you just find the complementary of x, which is x prime, and then you can work from that. So basically now what we're looking for now, we're looking for the possibility, we're looking for the x prime formula that's going to tell us that that's equal to the probability that x is more than and equal to 26, which is this whole entire part, right? So now basically now what we're looking for is that probability of x prime is less than or equal to 6. And fortunately, we can find that in our table. So we're going to look for table 8, and then we're going to look for the n, which is 32. Look for the r, which is 6, and that is, and look for the probability, which is 0.3, because we've converted the possibility of failure to 0.3. So now 32, 6, 0.3 is 0.1131. 0.1131. And that's your answer for B, part A. And then we're going to go on to the second part, which is, Roman numeral 2, which is asking us for the probability that x is between 20 and 25 inclusive of the accidents, right? So I can erase all of this. Okay. So now we're looking for the probability that x, right, is greater than or equal to 20 or less than or equal to 25. Okay, so here we're just looking for a portion of stuff, right? So, but because we know from the first question that we did that 0.7 isn't in the table, we have to use x prime again. And we know that 20, 21, 22, 23, 24, 25 are all the possibilities of x, right? So we're looking for this region in terms of our x. But in terms of our x bar, we're looking for just the point of reference nyana is that in order to know you're going in the right direction when you're using your x and your x bar, the x plus your x prime must equal to 32 or must equal to your n, right? So 20 plus 12 is equal to 32. So you know you're in the right track. So now what we're looking for the region where x is between 20 and 25 inclusive, the probability of that, which is the same as the probability of this, right? So we're saying that the probability that x prime is less than or equal to 7, is more than or equal to 7, less than or equal to 12, right? Mm-hmm. Yeah. And then we're going to use the table. But the table doesn't give us a region of area, sorry. So then we're going to have to convert this so it's easier for us to work with, right? So then we're going to look for the probability that x prime is less than or equal to 12, right? And then we're going to subtract. It brings us back to the question you asked earlier of why am I going to use that 25? I'm going to use the 6 here. That probability that x, when I remove this, that x is less than or equal to 6. The reason why I use the 6 here and not the 7 is because the 7 is inclusive in the area that we want. And we're looking for anything because what we did in our timeline is that we said we're looking for 12, right? Mm-hmm. And everything that's less than 12. But basically what we're looking for, we have to stop at 7. So now this is moving past 7. So we have to remove this area, which starts from 6 downwards. And that's why we remove it 6 inclusive all the way down. And when we go to our table, we have 30, we're looking for 12.
So, should it be the dash thing on the x?
Thank you. Yeah. And then we're going to have 0.8674 minus, looking again for 30 and 6, which is what we got in part A, which was 0.1131, and put that all in a calculator. 0.8674 minus 0.1131 gives us a 0.7543, and you're done. Thank you.